Okay, hello again. So, time we'll deal with another cyberdefenders.org. So, the good thing about these challenges is you get to deep dive on the incident, and you get to learn a lot doing forensics, be it host, network. This time we'll do the fourth installment of the Malware Traffic Analysis Challenge, Part 4. Of course, download it first. You have to register. You could register for free. Very good platform to train. Yeah, it is. Uh, this is the challenge details featuring two company users, Gufus and Galant. So you can see here, they're both SOC. Okay. So the story, Tuesday before Thanksgiving, Tom and Jake are working. Okay, Tom is the Windows guy. Jake is the one using Linux. And as you know, Windows are the most prone to infection, and coupled with Tom's unethical browsing, so he got this error, suspicious network due to network suspicious activity. You get the blue screen of that, and then the aftermath. Tom's machine got this suspicious registry entry in the run key. Okay, and there are also uh, Suricata detections right here. Okay, so Tom is in the hot seat in this situation. Okay. Okay, with that out of the way, so once you have downloaded and you have transported it into your analysis machine with a Wireshark, preferably with a Wireshark and a Brim and the network miner, because we'll deal with pcap analysis here, then you will be good to go. So number one, what is the victim IP address? Okay, so the first thing you could look for is the Brim. Open the pcap in the Brim. Go to the Suricata alerts by category. Of course, we're interested in malware infection here as the victim machine, so we could filter this log. This one, pivot to logs, and as you can see, there are only one private IP here, and then that's which fits as our answer. So this is definitely the victim machine, as you can see here. Okay, so next, what is the victim's host name? So this one we'll use Wireshark. You can open Wireshark right here, and we can filter the IP address of the victim. Okay, we'll scroll up. Of course, you can look for NBNS. No, NetBIOS name service. You can see here the query for that host name. So as you can see here, we got the turkey-tom. Actually, it's also shown here in the MNR. Also shows here turkey-tom. Okay, that's how we get this. For the third, what's the exploit kit name? So for this, we can actually use Brim again. Suricata alerts by category. So sometimes Brim is able to detect the exploit kit signature, but for this case, there's none. So what you can do next is check in the network miner, open it in the network miner, and check and let it scan for the downloaded files. And if you've been familiar, common exploit delivery, common file exploit delivery mechanism being used in, as we know, are Word doc, PDF file, or even flash files in the form of SWF. So we could search here some Word or PDF. So we could sort this by extension. Let's search for a Word. can see here, no word file here. How about PDF? Okay, just ping, right? So, and as well, how about XLS? Also XLS, just XML. But as you can see here, we have a couple of flash files here. Okay, we could actually, the beauty of Network Miner, you could right click it, open folder. Then what you can do here is, it automatically extract the file from you from the pcap, and you could look it up on the virus total. For example, this one, look it up, something malicious or some malware detection. So this one is clean. So actually I did it for all this SWF files, and the last one is the one that is malicious. So we could open the folder here. Okay, and we could look it up in the virus total. This one. Okay, and as you can see here, it's definitely malicious. 29 hits, 29 AV vendors. And actually, the hint here, if you will check the hint, it says here definitely scan it using clam AV to check the related exploit. And true enough, the clam AV gave the accurate reading that it is an Angler malware exploit. Okay, so that's how we got the Angler. So I'll just refresh this. Yep, that's Angler. Then what's the IP address that served the exploit? So it's already shown by the network miner. So this is the IP. We can look it up, and this one. So it's clean now because this is an old challenge actually. Okay. So that's the IP hosting the exploit. And for the fifth, what is the HTTP header used to indicate the flash version? So from the network miner, you can see here the packet, the frame number. So we could filter that in the Wireshark. 10960. Okay, and then expand the HTTP section and to check the headers. And you could actually see there this one. So this is the header that indicate the flash version. Right here. Right? E6. What is the malicious URL that redirects the server serving the exploit? So again, go back to network miner. If you recall, this is the domain hosting the exploit. This one, the SWF flash file. So what we're going to do is to find the referrer URL that redirects to this domain hosting the exploit. So the easiest way to do that is through Brim. So filter the activity overview, particularly the HTTP pivot to logs. Okay, and then we are interested in, we can sort the host. Okay, sort it A to Z. Oh, sorry, A to Z. Then let's go check for this host, new house Horacus. Okay, new house. Of course, you can sort it by time as well, but this is, I think, the easiest way to filter. So as you can see here, new house Horacus, and then we are interested in the referrer URL. So since there's just a couple, so we could eyeball it. So as you can see here, there's only one that stands out. The other referrer is also the same domain. besides this, which is the answer. So this is the solution. This is the refer URL that redirects to the domain serving the exploit file. Okay, so that's the answer. Okay, so for number 8, number 7. What is the topic ID corresponding to the technique used to redirect the victim to the exploit server? So more info at capic.mitre.org. So it's like a MITRE as well, but they have a different ID ID assignment on how they map the technique. So recall on previous question we found this. Okay, this is the malicious URL that redirects to the server serving the exploit. So what we're going to do is find the exact packet that contains uh, this malicious JS file. So here we have the pcap open. So let's search weather.js. Okay, and we have here the frame number. So let's filter that on Wireshark. Okay, let's go back to Wireshark. Okay, I've framed. Sorry, so frame. Okay, frame that number. I actually have here in history. So 10552. Just click enter, and this is the exact packet we are looking for. And then what we're going to do. So recall here, this is the exact malicious URL we find in the previous question. So what we're going to do is right click, follow HTTP stream. And as you can notice here, this is the exact HTTP stream, the malicious request. And what we will get here is the usage of, notice here the usage of the iframe here. So the request to the shotgun world has an iframe that redirects to the domain hosting the exact exploit, which is this. And then a quick search of that technique, actually I have here. So topic iframe. Okay, so you see here the answer is in the first result, CAPEC 222. So it's an iframe overlay technique. Okay, you can read it more to know about this technique, but that is our answer, as you can see here. All right. And then for number 8, what is the FQDN of the compromised website? So we have found it here in the Wireshark. So notice here, this is the compromised website. You have to trace back. This is the compromised website that lead or referred to the domain hosting the exploit, which is this one. Okay, so that's how we found the shotgun world. Okay, and then lastly, I'm second to the last, number 9. The compromised website contains a malicious JS that redirect the user to the website. What is the variable name passed to the document.write function? So again here, we found here, right? This is the compromised website. So we're going to search that in the network miner. Oh, I have a typo here. Okay, and then we'll filter the JS file. We can sort it by extension. Okay, we just have 3 actually. And then we check the one with the bigger size, so because it has more contents. Right, so this is about, see here, 1479 bytes. And as you can see here, this is exactly the variable we are looking for. Or you can check here the other one, it's 52 bytes, but you cannot find much. Yeah, though there's also a variable. I think it's the same variable. Oh no, it's a different variable from the one with the bigger size. This is the one that we are looking for. Okay, so that's how I found it. And then on to the last question. This is the easiest one. What's the compilation timestamp the malware found in the machine? Found this and recall in the challenge details. There's a malware found here on the machine, on one of the machine. So it's actually down here, there. So on Tom's machine, suspicious registry was found, and there was a 256 hash for the malicious file. So we're just going to get this and look it up in VirusTotal. So simple look it up, which I already have not yet. Okay, simply VirusTotal search, and it's supposed to get the answer. As you can see, this is a very malicious file. Details, you could actually find the compilation time and the creation time there. Okay, so there you go. Hope you learn a lot.